But salt formation can happen even in the absence of water. After giving out H plus ion and receiving out H plus ion, it will form conjugate pairs of acid as well as base. Arrhenius concept does not explain the acidic behavior of substances like BF3 and aluminum chloride in water. Hello everyone, this is Harshita Bhavasar from Vidhyaashram School of Excellence. Today I am going to start about session 5 from the chapter Chemical Equilibrium. In the last session, we have discussed about factors affecting equilibrium and ionic equilibrium. In that, strong electrolytes and weak electrolytes also we have seen. In today's session, we will see acids, bases and salts, the just introductory part, and hydronium and hydroxyl ions and periodic trends in acidic properties. These are the three concepts we will see in this session. First we will see acids, bases and salts in that Arrhenius concept. Before moving on to the acids or Arrhenius concept, there are two or more concepts about acids are there, like Arrhenius concept, Lewis-Bronsted concept or Lewis concept. More concepts are there. According to individual scientists, some of the individual perspectives are there. So we have to go through one by one. First one, Arrhenius concept. According to Arrhenius concept, an acid is a substance capable of ionizing in water to give H plus ions as the only cations, and base is substance capable of ionizing in water to give only OH minus ions. According to Arrhenius, what he is telling, ionizing means the separation of ions. Okay, in the water, an acid should liberate H plus ions and base should liberate OH minus ions. See here, if an acid HA means it should liberate H plus and A minus ions. Example, acetic acid CH3COOH, CH3COO minus plus H plus. Okay, this is undergoing partial ionization, but also it is an acid, it is going to liberate H plus ion. In base, MOH giving rise M plus OH minus. Example, ammonium hydroxide giving NH4 plus and OH minus ions. Acid-base neutralization involves the reaction between H plus ions of the acid and OH minus ions of the base to form feebly ionized water. See here, H plus OH minus will give water. In the reversible reaction also, water will get ionized into H plus and OH minus ions. Arrhenius classified acids into strong and weak acids and bases into strong and weak bases according to the extent of their ionization in water. What Arrhenius did? Arrhenius, after predicting or after telling about acids and bases, he classified acids as strong acids and weak acids, also bases as strong bases and weak bases based on the extent of ionization in water. Strong acids and strong bases undergo almost complete ionization in water, but weak acids and weak bases undergo partial ionization in water. Partial means half or more than half, that much only ionization will take place. Those kind of acids and bases will considered as weak acids and weak bases respectively. If it undergoes complete ionization means strong acids or strong bases. For strong acids, HCl, hydrochloric acid, sulfuric acid and nitric acid all will liberate H plus ions and completely get ionized. Strong bases, OH minus, here sodium hydroxide, potassium hydroxide and calcium hydroxide. Weak acids, acetic acid, ethanoic acid and carbonic acid. Weak bases means ammonium hydroxide, which undergoes partial ionization. This is about the Arrhenius concept and also its classification according to him. Next, hydronium and hydroxyl ions. Hydrogen ion by itself is a bare proton with very small size and intense electric field binds itself with water molecule at one of the two available lone pairs on its giving H3O plus. Hydrogen ion itself a bare proton H plus, okay, that will binds with the water which is having lone pair of electrons in oxygen. It will binds up to give H3O plus. This species has been detected in many compounds in the solid state. See here also H3O plus will be identified, which will be in the solid state. In the aqueous solution, the hydronium ion is further hydrated to give species like H5O2 plus H7O3, H9O4. In the solid state, it will stop to H3O plus, but in the aqueous state, it will be further get hydrated like H5, H7, H9 like this. Similarly, the hydroxyl ion is hydrated to give several ionic species like H3O2, H5O3 minus and H7O4 minus, etc. See here, for this lone pair of electrons present in the oxygen, another hydrogen will get attached. It will form H3OO plus and another will form H5O plus like this. Due to this lone pair only, it is getting hydrated more and more. Next, limitations of Arrhenius concept. What are the limitations of Arrhenius concept? What he could not explain. So, we will study one by one. Arrhenius concept can be used only in aqueous medium. In the aqueous medium only Arrhenius concept can be studied, like in presence of water. For example, HCl in aqueous medium is an acid, but HCl gas is not. Okay. Arrhenius concept is not useful for non-aqueous medium. Means in the aqueous medium only all the acids can be studied or all the bases can be studied, but other than aqueous medium we cannot study or we cannot implement this Arrhenius concept into any acid or any base concept. Neutralization is limited only to substances that are capable of ionizing to give H plus and OH minus ions. Neutralization means acid and base gets neutralized to form salt and water. This neutralization is limited to only to substances that are capable of ionizing to give H plus and OH minus ions. Which substance which liberate H plus ions and other substance which gives OH minus ions, based on those two substances only neutralization will takes place. So, according to him, which are the substances which liberate H plus ions and OH minus ions, there only can be studied Arrhenius concept. Other than the substance which does not liberate H plus and OH minus, we cannot study those concepts. But salt formation can happen even in the absence of water. Okay. Arrhenius concept does not explain the acidic behavior of substances like BF3 and aluminum chloride in water. Arrhenius concept does not give any idea or does not explain any acidic behavior of substances like boron trifluoride, aluminum trichloride in water. Acidic nature of some non-metallic oxides and basic nature of some metallic oxides and amphoteric nature of some oxides cannot be explained by Arrhenius concept. At last, acidic nature of some of the non-metallic oxides also cannot be studied. Some as basic oxides also cannot be studied and amphoteric oxides also cannot be studied. Okay, these are the limitations of Arrhenius concept. Once again, according to him, only in aqueous medium only we can study about acid and bases. Out of aqueous medium we cannot study any of his concept, and only substances which liberate H plus ions or OH minus ions can undergo neutralization and studied only those compounds in his concept. And Arrhenius concept does not explain any of BF3 or AlCl3, these kinds of compounds, and acidic nature of non-metallic oxides, metallic oxides as well as amphoteric oxides cannot be explained by his concept. So, the Arrhenius theory was failed or due to these limitations. Next, Lowry-Bronsted concept. According to Lowry-Bronsted concept, an acid is a proton donor and a base is a proton acceptor. Proton means you know H plus ion. It should, whenever H plus ion is donated, it will be acid. Whenever H plus ion is accepted, that will be base. Example, hydrochloric acid treating with water, which is a base, which can act as also base or acid, which gives that H2O will accept H plus ions, means here water will be base. It is liberating H plus, so it is a acid. See here, HCl is an acid as it donates a proton to water, and H2O is a base as it accepts the proton from HCl. According to his statement, acid is a proton donor. This is an acid because it is liberating H plus ion. Base is a proton acceptor, so water molecule is accepting H plus ion. In the reverse reaction, H3OO plus acts as the acid and Cl minus acts as the base. In the reversible reaction, this will be acid and this will be base from a conjugate pair. Similarly, water and H3O plus forms another conjugate pair. In fact, any acid-base reactions may be considered to produce the conjugate base of the acid and conjugate acid of the base. Here, after giving out H plus ion and receiving out H plus ion, it will form conjugate pairs of acid as well as base. See here, conjugate pair acid 1 and base 1 and another base 2 and acid 2. See here examples, HNO3, that is nitric acid, in water it will liberate H3OO minus and nitrate NO3, and in acetic acid also with reacting with H2O, CH3COO minus H3O plus. In H2SO4 sulfuric acid also treating with water HSO3 minus H3O plus. In water and water OH minus and H3O plus. And in ammonia and ammonia NH2 minus NH4 plus. Ethanol C6H5OH with water C6H5O minus and H3O plus. These are the examples of formation of conjugate pairs of acids and bases with acid 1 and base 1 and base 2 and acid 2. This is about Laurie-Bronsted concept. What he finally concluded, stronger the acid, weaker its conjugate base and vice versa. See here, stronger the acid and weak acid, stronger conjugate base. Some substances are capable of acting both as proton donor and proton acceptor. They are called amphiprotic. Like examples, ammonia, water, acetic acid, etc. It can donate H plus also, it can accept H plus also. So, it will be acting as amphiprotic. Okay. See here, water plus base, and here also H3O plus will be forming, and in acid HSO4 minus will be, and that acid will be formation SO4 minus 2, and here also ammonia giving out ammonium NH4 minus and NH3, NH2 is forming, H2S, HS will forming, HS, S minus 2 is forming. So, here stronger the acid, weaker its base, it will form conjugate pair, and overall how that H plus ion is accepting, how the H minus H plus ion is donating or accepting concept can be explained. Next, strength of acids. The strength of an acid is based upon its ability to lose its proton, and the strength of a base depends upon the ability to gain the proton. Strength of acid means based upon how they are telling means acid, if it is losing its electrons or losing its proton, then we'll consider it is a strong acid. Base accepting or gaining the proton means it is a strong base. How much it will accept or how much it will donate, based upon it, strength of acid or base will be recognized. The strength of an acid also depends upon the solvent. In aqueous medium, the acid HClO4, H2SO4, HCl and HNO3 have almost the same strength, but in acetic acid, the order of strength of the above acids is HClO4, H2SO4, HCl and HNO3. Strength of acid will also depends on solvent, means in aqueous medium, number of acids will have the same strength, but in acidic medium, the order of the strength will be differs. First HClO4, next H2SO4, next HCl, next HNO3. Thus, the real strength of acid can be judged in a solvent which is weakly basic. On the other hand, in ammonia, along with the above acids, even acetic acid behaves equally strong. Thus, HCl behaves as a stronger acid in ammonia and acid in water, a weak acid in CH3COOH, neutral in benzene and a weak base in HF. See here, the basic character increases like from HF to ammonia. Okay, so ammonia is the strongest base, next water, next CH3COOH, next benzene and HF. It means the strength of acid also depends on solvent, not only the H plus accepting or donating. Next, periodic trends in acidic properties. You have seen many periodic trends in the classification of periodic table. Now that trends which also involves the acidity or basicity also. Hydra acids of elements of the same period. Consider the hydra acids in second period. CH4, that is methane, ammonia, water and HF. The order of increasing acidity is from methane to HF. Here negligibly acid, here fairly strong acids are there. The increase in acidic nature is due to the fact that stability of their conjugate bases increase in the order of CH3 minus, NH2 minus, OH minus and F minus. Due to this, the proton donor capacity is there, and also after donating also stability is there. So they are judging like this. Next, hydra acids of elements of the same group. Hydra acids of 16th group elements H2O, H2S, H2SC and H2TE show weak acidic properties. The strength increases in the order. From the water to tellurium, it will form. Next, hydra acids of 17th group elements from HF to HI show higher acidic nature. Their acidic nature increases from the HF to HI. This is due to the decrease in electronegativity of the halogens. Next, oxy acids. In the case of different oxy acids of the same element, acidic character increases with increase in oxidation number. Means whenever the oxidation character will increase, oxidation number will increase, their acidic character will also increase, because loss of protons will be keep on moving on. More the number of the terminal oxygen atoms present, more will be the electron shift and greater will be the acid strength. See here, HClO only plus 1, here O2 only plus 3, O3 plus 5, O4 plus 7, H2SO4 plus 4 and here plus 6, HNO2 plus 3, HNO3 plus 5. This rule fails in the case of the oxy acids of phosphorus, H3PO2, H3PO3 and H3PO4. Oxy acids, what he told, increase in oxidation number, increase in acidity, that rule does not accepts here, where he failed out to show that rule. Acidic character of oxy acids of different elements in the same oxidation state decreases as the atomic number increases. Thus, HCl4, O4, HBrO4, HiO4, H2SO4, H2SeO3, these are all showing the examples. And shortcomings of Lowry-Bronsted concept, there are a number of acid-base reactions that do not involve any protons, and there are so many reactions that does not involving any proton, but also it is showing acidic character also. Here see no proton but also acid, and here base, it is forming also acid and it is also base. Because of oxidation number we can judge. Protonic concept cannot explain the acidic and basic characters of substances like BF3 or AlCl3 etc. Here what we have to understand, only protonic character only does not explain the acidic character. Out of that protonic character also acidity or basicity is present, that we have to understand. This is about the Arrhenius concept and Lowry-Bronsted concept and also their limitations. In the next session, we will discuss about Lewis concept, limitation of Lewis concept, ionic product of water and the pH scale. I hope you have understood completely whatever I have taught today. We will meet in the next session. Thank you.